So we've talked a little bit about subroutines already. So what did we say about subroutines already? Hmm? Of course, the subroutines that we're going to do are in the lab are really small little subroutines. Well, what we can do, no, you can't make a big one into a small one. We take a big one and we split it into modules. So the program is not short because all subroutines is part of a program. Okay. Describe the function of subroutines in the PLC logic diagram. Create PLC logic diagrams. Incorporate one or more subroutines. I can't remember in our lab. I think we do it with like 3 subroutines. Create ladder logic diagrams of subroutines. Name and rename subroutine files. I showed you how to do that, right? Conditional, unconditional. So unconditional subroutine means what? There's no input, right? You understand that, which means every time that rung is scanned, it will run that subroutine. A conditional subroutine would have some type of input on the left-hand side where it only runs when certain conditions are met. These input devices called subroutines. This is if they're conditional. I need to move that over. So we can use a compare instruction. We can use input instructions, or a compare instruction is an input instruction to set conditions. So how do we create subroutines? So here's the guy. Here's the true guy, right? So let's say I want to put a subroutine in this program. What would I do? I'm not going to add a data. I'm not going to add a data file. Data file is memory. We want to add another section to our program. Right. In fact, let me I want to add another section to my program. Okay, so I'm going to call up the program files. And then what am I going to do once I get there? Right click, and do what? New. Now automatically it's going to go to 3, but you don't have to put them in order if you want to. It's going to file 3. Why? Because the first 2 file numbers are used by system files, 0 and 1. Then ladder 2 is your main file, right? You understand? And then after that, the first one available will be 3. And what do you need to do? Odds are you're going to assign it a name. Normally what we try to do is we try to give it a name on what the subroutine does. That makes sense? So we'll look at the subroutines for us. So as soon as I do that, over here in my program file, I get another program file in ladder 3 called SUB. By the way, we can rename this one. I can right click on this one, do what? Rename, and I might call this main. So notice the tab changed to main. How do I get that subroutine? So that's a subroutine. Ladder 1 would be your main program. We got to have a main program, right? You understand? And then the main program will usually call the subroutines. So how do I bring that tab up? Well, I'm going to come over here on ladder 3. I'm going to double click on it, and now I have my subroutine. Is this a different program? No. It's a module of the same program. Yeah. It's a module of the same program. You have to go, to get a new program, you would go up and put new program, right? You understand? It's one program. No, it's not a different file. It's the same program. It's one program that we split into modules. So we can't put another program inside. The only way we can create a new program is to go up here and do what? Go new, right? Everybody understand that? So this is a subroutine. And if I wanted to add another one, I would do what? Right click, go on program, go to new. This automatically assigns it 4, and I might call it sub 2, right? By the way, you can rename these. Let me make sure. I think you right click on the tab itself. There you go. And rename. And I could call this sub 1. Okay, go ahead. Yes. Now, one thing you got to be careful about, you got to consider, is that if a subroutine is not running, then your inputs are not being scanned in that subroutine, and your outputs are going to stay what they are. So the only time you can update outputs is when the subroutine is running. Understand? Yeah. So we've had this happen a couple times, and we'll see that. I'll demonstrate this when y'all put this program in. What do you mean? Well, you probably wouldn't do that. Both subroutines would be true, and it would run both subroutines, and that's something that you would have to do what? Yeah, you'd have to fix. Normally, we wouldn't do that. Uh, we wouldn't try to put that. You can repeat rungs, by the way. Some of y'all have gotten problems with that. The problem that y'all have had, and the problem is if you use output another time, you don't get an error. When you check your compile, it's not an error because everything's in the right syntax, right? You understand? But what's been happening is some of y'all that's duplicated outputs. Well, if one output says it's off and the other output says it's on, then it just stays off, right? You understand? But what you can do is you can duplicate a rung and use the same output. So if you need an output to be monitored in different subroutines, you just do what? You repeat the rung, and the rung's got to be exactly the same. That makes sense? So how many subroutines? What determines how many subroutines we can have? Yeah, how much memory you got in your PLC? Yeah, right. How much memory you got? How many timers you're going to use, and all this other kind of stuff. Okay. So what we would do, I actually need to start a new program. In fact, I think I got one with subroutines in it. Let's look. No, it ain't. What's the one in the book? I don't know. Well, it's not. It's called a JSR. There's a difference between a jump and a jump to subroutine. For one thing, a jump is inside a program module. A JSR, which means jump to subroutine, is going to cause a subroutine to run. Now, what we have to have inside the subroutine is that the first one is optional. Let me bring my program back up. So usually in the first rung of the subroutine, you would have a SBR instruction. Isn't it SBR, guys? Y'all help me on that. One that identifies the subroutine. So these will be inside the program control. As soon as I find it, program control, jump, label, JSR, return, SBR. So the SBR instruction is an optional instruction. SBR. But we usually use it because it identifies this as a subroutine. So the SBR, notice what side of the rung did it go to. So what that means is if I come over here and try to verify this rung, it's going to be, it says I'm going to have a watt. It says the rung, I'm missing a watt output. Okay. So if we do use an SBR instruction, then you're going to have to use it. You're going to have to use an output instruction, not necessarily an output, but an output instruction, right? And normally we would use what file? Yeah, what are B3? It's good. Yeah. And then what we do now, notice when we clear it, it's going to clear out. So that means the rung is okay, right? Okay. And then what we do at the very end, oops, one more rung, Rich. I don't want to do that for me. So our rungs that was in the subroutine, we would put here. So this would be inside the subroutine. And then what we do, the last rung before the end, what we would use is we'd use a, oops, I know, I didn't mean to check my file. We would use a RTE instruction. So the RTE is required. And what would that mean? What would the return instruction cause to happen? Not to the beginning. To the next rung in the program that called it. To the next rung in the program that called it. So it would go over here in my main program. I'm not going to change it. So ladder 2. So down here, I would come up and I would say, okay, so I'm going to come right here and I'm going to insert a rung. And then down here, I'm going to put a JSR instruction. This would be unconditional. Okay. Now, what we have to do is we have to, so we don't address, we give it a number. Okay. So what we do on the jump instruction is we start the jump instruction with a number. We start off with a U. Oops. U. Then what we do is we put the file number of the subroutine I want to go to. So I wanted to go to, this is subroutine 1, which would be this guy right here. So I would come up here and put a what? I would put a 3. That's file 3. The subroutine is file 3. Okay, understand. Then I hit enter. And we can assign it a symbol so we can give the, yeah, we'll give it a name. Okay. So we'll check to see if I did that right. So we'll check and see if it compiles okay. And it did. So what we do is the subroutine we want to go to, we put U : and then we put the file number of the subroutine I'm going to go to. This is what? This is file number. This is a file. Program number. So this is the program I'm going to. So I'm saying go to what? 3. So every time this program ran, when it hit this would be what we call an unconditional subroutine, which means what? No input. If I wanted to make it conditional, I would put input. Could be compare instructions like this number is this, then do and run the subroutine. That makes sense. The return, so what happens is when it hits the JSR instruction, the processor automatically saves where it's at. It's called a stack, which is a piece of memory that's controlled by the microprocessor. Then it goes out there and runs the program. And when it hits the RTI and RTE instruction, it pulls the stuff off out of the stack. And it would come back to what it would come back where? It would come back to 5. It's going to come back to the rung after the JSR when it sees a what instruction. instruction return. What if we didn't have the return instructions? It would never come back. So we do that every once in a while I'm troubleshooting. If I want to troubleshoot the module, I just return that. That way the sucker will do loop that one little program until I get ready. We can make the return conditional. So I could come over here and put a contact right there or something there, and it would only return when certain conditions are met. So I might counter and I say, okay, I want you to run this thing 5 times. And once it goes through the program 5 times, then it would do what? Then it would return. So the return instruction can be conditional. The SBR instruction is optional. We're going to use it in this class because this identifies this module as a subroutine. So I know that this program, this part of the program is a subroutine. I know it's not the main menu, right? You understand? So the main, but we could also do this, guys. I could come over here. It's not, once you get over here, guys, it's basically, it's a lot easier to use this guy. So I'm going to come over here and I'm going to put a JSR and I'm going to put it right here. And over here, I'm going to say U:4. And the name we call it is so what would this do? So I would come out here to sub 4, which would be file 4, and I would build a program. And down here, I would come over here and put a return here. Where did it go? Now, where would this guy go back to? You're exactly right. It would go back to the program module that called it nested subroutines. Subroutine calls a subroutine. We call that a nested subroutine. N-E-S-T-E-D. Like a bird nest. Asking Rich how to spell it, but I do know how to spell nested. So what's a nested subroutine? Another subroutine. If the subroutine has nothing in front of it, it's what we call an unconditional. So this right here would be unconditional, which means every time it hits its rung, it's going to do what? It's going to run that subroutine. If I want to make it conditional, then I would do what? I'd add an input. Could be a compare instruction. So I could come over here and I could say equal to, and I could say, okay, if A is equal to 10, well, when A got, and where can A come from? A can come from almost anywhere, right? From any data file. So when A gets up to 10, it will run that subroutine. I think the lab that we're going to do is you're going to have a counter. And as your counter counts, depending on the counts, you're going to cause it to run. You're going to cause it to run one of the subroutines. In ours, the returns are not conditional. When would you make a return conditional? If you wanted to make the program loop so many times, if you wanted to wait on something to happen before you returned it back to the main program, then you could make it conditional. So both the JSR and the RET can be conditional. We mean we have a lot. We have some input over here, right? Everybody understand that? So subroutines are neat. I mean, this is it, guys. You literally want to have a PLC program that's long and they don't because you're trying to find something to split it up in subroutines. We give subroutines names according to understanding. So that's I didn't save that. Thank you. I hope I need to look at it and see if I did. Huh? So we got one more thing to look at. I'm gonna bring up the then we'll go to lab. Even though I did go past the time. So what I'm gonna do is what am I looking for, Rich? Oh, wrong class. So automatically, when you look in an Allen Brady Arts Logic 500, the only module they show you is ladder 2. So they're calling it T-org underscore org. And here's the tab down here. So you notice the first instruction in the program is a what? A jump subroutine, and it's going to go to what? File 4. So it's going to go to whatever this is right here, right? Okay. And then the next instruction is a what? Is an unconditional. So the first one is conditional. This is unconditional. So every time this main program runs, it's going to go out to what file number? 6, which would be this subroutine right here, which is called emergency blink. So this causes some lights on the front panel of the PLC to blink. Then they got one called P-stop. This is a conditional subroutine. So this is going to be the stop button, the S2, the stop button. So if I press the stop button, it's going to run a what? A subroutine that handles the stop. It's going to make the line stop in a organized fashion. This is conditional, but that's the actual stop button on the front of the PLC. These are some inputs. Here's that we're not going to talk about that guy. And and it ends up with a what? JSR. It's going to run what? 3. Now, how do I get those other how can I see those modules? All I see is PORG, which is ladder 2. That's what name they gave it. How can I get them down here? I'm just going to come up here and just click on them, right? Huh? No, you don't. This one you drag. You just click on them. So now I have all my subroutines. I've got them in order. So this is auto. Now this is EM stop. So this is emergency stop. So we'll talk about some of these instructions. So what they do is they just fill all the outputs with zeros. So if you fill all the outputs with zeros, that's going to turn all the outputs off, right? And these are cross couple. Remember back in PLC 1, we looked at the cross couple timers, which causes a light to flash. So this causes lights to flash. So this is a subroutine. So what they've done is they've taken a big program and done what? Split it into modules, and now I can troubleshoot the modules, right? Everybody understand that? Okay, guys, let's go to lab.